Good. All right. I'm going to give a brief introduction now to the ODK, showing two separate things. So one is how to set up your own repo very briefly, and also talk slightly with a bit more the Monarch developers in mind, like the general design. So how do we, so why did we design the ODK as a whole as we did? And we'll walk you a little bit through the architecture of the software. But at first, so just quickly a few links. So this is the GitHub repository for ODK. This here is the tutorial that I will show, that I will walk you through now. So you can always go back and read it up and repeat it yourself. So this is kind of like how do you set up your own repo. And this here are just some beginning thoughts on the ODK and what it actually is, but I have just started writing it, so nothing much to read there at the moment. All right, so the first thing, so before I start, I just want to say two things. So we don't have much time to really go into the weeds here, but since we have 3 minutes more, I would just want to say that when we say ODK, we are talking usually about two things. So I always say when people think, what is the ODK? I will always answer this is essentially two different things. And the one is, it's a toolbox. So the ODK bundles frequently used tools that are used for managing the ontology lifecycle together, like tools like robot, owl tools, some validation tools, DOS-TP, Jenna, and many others. And also, it's also a system or a methodology for managing the ontology lifecycle, that from things like continuous integration, how to do quality control, how to do dynamic importing, and how to manage the releases of your ontology. So whenever someone says ODK, you need to make sure are they talking about the one or the other? They're two different things, both called ODK, and we will talk about both a little bit today. Okay, so maybe this is maybe going a bit too far for today. ODK has lots of tools in it. You could check out so it's bundled as a Docker image. So you can check out the Docker images if you want to see what kind of tools is bundled. But one of its key functions or tools, let's say, is the seed my repo tool itself. So that is a tool that is bundled inside of the Docker container that allows us to create an ontology repository, like, for example, like most of, I think like 90% of the ontology repositories in the Monarch wider spheres, they have like a very common layout. Yeah, you can see you have your release files up at the top level. You have like your source files in the SRC ontology directory, where you have like an edit file and a bunch of other configuration files as well. So what this ODK function does, it will create like a small version of this, like a repo structure that allows you to manage an ontology and does all these things for you, like how do you do your dynamic imports, how to run your continuous integration testing, and all of that is bundled up in there. So we'll look a little bit more when we are actually creating something in a second. So, okay, so let's go through the tutorial. So what you need before you start is you need to have a GitHub account. I guess everyone here does have one. And you should have completed these preparations, which is basically installing Docker, installing the ODK, which is simply Docker pulling the ODK container, and making your memory settings. So all of this is described here in detail. I'm not going to go through that, but you should always revisit this, because one of the main things, like for people that that start using the ODK, that trips them up is that they do not properly set up the Docker memory. And there are like two kind of categories of errors you can fall under. One is you set the application memory higher than the total available Docker memory, which will cause some super cryptic error messages like error 137 or some such. or the other way around, you set the application memory to low, and which will cause the usual memory out of memory errors and so on. Okay, so you set yourself up, you have your GitHub account, all great. So now creating a first repository. So the first thing we do usually is we create a little temporary directory. So I'm going to go to my home directory now. This is not where I usually put my my projects, but doesn't matter since I'm going to delete this file anyways, this directory later on again. So I'm just creating myself a temporary directory. I'll go inside, and then so the first thing I need to do here is I need a kind of little wrapper script. You could copy what's in that wrapper script and run it straight on the command line, but it's a bit involved because like invoking Docker containers on the command line is super bulky. So what we do is I'm just going to download the script using wget now. And I'll show you how it looks like. So this is how it looks like. You could, in theory, just run this here as like one ugly, huge thing on your command line if you wanted to. But yeah, so we recommend just download the wrapper script, just the shell script. Okay, and now the second step of your part is to download a basic configuration file. So one thing you can do is you can look at one of the many configuration files that are already in the ODK directory. There are many others as well out there in the wild that you could look at. Configuration files, we'll discuss some of the sections a bit more detail, but conceptually they are like the most important artifact for managing your ODK installation. So your the repo structure, and it covers things like the IDs, what kind of release artifacts you want, what kind of imports you want to configure, and stuff like that. So it's all of the kind of configuration related to your specific ontology. What we will do now here is instead of downloading it, I'm just going to actually physically create one. So I'm doing this here in just for illustration. I'm just doing the nano. Oops, sorry. So I'm decided to create the cat ontology. So cato odk.yaml. Okay, so what you see here, so I'm adding a bunch of stuff into this config file. So I'm just making it a bit bigger. I know that you probably don't see this very well. So you can see here, I have an ID up top. And then after that, I added a title. The ID is like really crucial. It's a lowercase string. Typically, we want to have a string of at least length 4 or length 5. So we recently in OBO Foundry started actively discouraging ontology IDs with 3 characters or less. Then we have a title. This is something that will be reflected in certain parts of the auto-generated documentation. Then you have you give a GitHub organization and the name of the repository that you will use for this repository. So I use here just cat anatomy ontology. And then this is a bit important because I guess you all remember, like a bunch of years ago, the default name for the main branch was changed from master to main. And this in the ODK, the default is now also main. But if you are working on a legacy GitHub repo, for example, when you want to migrate, then sometimes you want to change this here to master branch. Then you have things like this, configuring like these release artifacts. So here you can see I want to release. So first of all, maybe for some of you that don't even know at all what I'm talking about. So the idea here is that you have like one kind of source of truth file that is the edit file plus minus. So there's probably a set of edit files, I would say. And the ODK will give you something like, let me see whether I can quickly open up one here for Uberon, for example, so that you get a sense of what this does. It will give you, it will create like this structure that I showed before, but in particular, it's going to create a make file that encodes a bunch of rules of how to create, for example, release artifacts. So what I mean by release artifact is a version of the ontology that we want to present to a user. So this version of the ontology, for example, has a version IRI, has all the imports merged in, and may have some other pre-processing applied to it. And there are various different kinds of release artifacts. And these, the way that they're constructed, this is all controlled in this make file here, which is beyond the tutorial today. I just want to mention there is a place in this repository that gives you things, says something like, okay, if you have in your configuration, like you see here, release artifacts simple, if you said, I want a simple release of my ontology, then in the ODK, you will see in the ODK makefile, you will find a goal that creates this simple artifact and then provides a rule on how to create this simple artifact based from the edit file. So the file that your curators are interacting with Protege or with DOSDP patterns or robot templates or some such. Okay, but this is a little bit beyond today, but just to get a sense. So here we say, all right, in this particular ontology, I want to release my ontology as a base file, as a full release and as a simple release. And in this tutorial here, I provide also a link on that you can read up what are these here. Every new ontology should always release a base and a full release. This is also default. If you don't add that option at all, a base and a full release will be created. And then you can say also, what of these release artifacts do you want to be my primary release? So as we seen before here, for example, for, sorry, I need to move this thing out of the way a bit. We've seen for Pato, you can see there are many different releases up top. And there is this specific one, which is called just pato.owl. So this is hp.owl, uberon.owl, any kind of ontology has that file. This is what we call the kind of primary release. And here we say, we tell ODK, okay, I want the full release to be my primary release. Again, this is also the ODK default. You don't have to include this option. This is just for illustrative purposes. And then we have the export formats where you can say something like, okay, I want this ontology to be, I want these releases to be exported as OWL, OBO, and JSON. So for Pato, you can see here, pato.json, pato.obo, pato.owl. So this will be, ODK will take care of generating all the different serialized exports as well. And then you also say, okay, in my ontology, I want to dynamically import relationships from RO, from the relation ontology, from Pato, and from the OBO metadata ontology. And you can put any ontology in here that you want. So it doesn't have to be an OBO ontology. It can be any ontology that you can think of. You can add as an import here. And there are like lots of different options on how to configure the imports. By default, what will happen is that ODK will create what is called a syntactic locality-based module from all of these, and that's a terrible mouthful for saying what Chris and many others here have come to call a SLIME module, SLME, which is basically a logically coherent small subset of the main major ontology, so the whole ontology subset of it that covers all the needs of your specific ontology, and ODK takes care of what it means cover all your needs. All right, so I'm going to make this a bit smaller so I can see where I'm at here. Okay, so this now I've created this this configuration file. So now the next step here is to run this configuration actually. So make sure that you are in your directory where you've also put the via Docker shell script and your config file. And so now you see we will run this shell script, invoking it, giving it with the concept, the config file with -c. The little -c here just means if you run it multiple times, delete the old one. If you don't put this, it won't do that. It will probably just fail. So basically, just always run -c, lowercase, -c, uppercase. Okay, so now you can see a little bit. It will take a few minutes, but you can see here that what happens here in the background is that so this here goes inside of the ODK container. And then you can look, like if you know a little bit about like templating system, like Jinja, you can see there are lots of like little Jinja files that are inside of the ODK container that are being called against our config file. And these files are then translated into proper, they're then materialized here as proper as proper files in our file system. So here you can see we compile the update repo.sh.jinja2 template file to update repo.sh. This is just for people that are interested in the technical underpinnings. This has no relevance for anyone who just wants to use the ODK. So it will go create all these files that are important for based on your configuration in this directory, applying various Jinja templates. And then when it's all done and all the files are correctly created, what it will do here, you can see it will first initialize a new GitHub repository. Then it will also add all the relevant files from this run to this GitHub repository. And then when it's all done and well, it will say, oh, it's all good, and you can continue. So this process, because we have to initialize it and we have to download some dependencies and all this kind of stuff, will take like maybe 2-3 minutes. I only added like very small ontologies here just to make this quick. But if you have like huge ontologies like Uberon or Cabby or Pro, then this process will take slightly longer. So you can expect at least, not slightly longer, it will take a bit longer, like an hour or something at least to initialize it. But now, yeah, let's see, in 1 minute it should be done. Good. So while this is running, are there any questions so far? Okay, no questions. That's good. So, or yeah, I don't know what that's good, but let's see. Let's say it's good. Many of you have heard this before, so it's probably not so much news to you now. So now, while I let this run a bit, I want to go and spend a few minutes on the technical implementation of the ODK. So, like, how did we design this? So recently, some people, so the core development team is basically me, Damien, and Chris. And Damien recently bought like an M1, so the first person that had to use Docker, that had to use the ODK on an M1. And so he kind of like revamped our entire Docker infrastructure to allow what is called multi-arc builds. So a multi-arc build is basically a build such that it allows us, we specify our, as we used to, our what we want in our Docker image in these Docker files. But then when we run the build, which takes a long time, like 10 hours to run or something, it will build this Docker image in such a way that it can be run on multiple different architectures, like, for example, any kind of ARM 64 processor or AMD 64 processor. And so structurally, what we've done is we have separated the ODK into two kind of bits. So we have the ODK full, which let's maybe start with ODK Lite first. So we have the ODK Lite container, which is a relatively recent thing that has tools like Robot, Owl Tools, even Ammonite, which I don't even think it should be in there for the light one, but it doesn't matter. But in any case, it's a much smaller set of tools. This container is around 500 megabytes in size, which is okay. So we've worked with the ODK, which has been like around 800 or 700 for most of the last 2 years. So it was okay. 500 is definitely a bit better. And then we have the main ODK full file, which is inheriting from this light version and then extending it to have things like Jenna, a bunch of new command line tools, the OBO dashboard, and the Swipple stuff, Sparkle Proc, and all these kind of things. So lots of cool additional things, so that people that want to use the full test suite, they will go and so the full number of applications, sorry, they can go and use the ODK full. Most normal people will be able to get away with just using the ODK Lite container. It will contain everything that is necessary, for example, for running releases or similar. Good. Before we move on, because it's finished here, I just want to say, so I kind of really like this approach. So I've been trying to use these things like this GitHub template things, like what people provide, like a GitHub template, and you go and clone this GitHub template somehow, and then you have like a repo there, and all of these things, they are not really as powerful as having a mechanism that generates using Ginger template, like the full repo structure completely from a configuration file. So I kind of like this system a lot, and we've been using it quite a bit. And I think that for something like COSA, for example, where in the future we would want to quickly generate new ingest templates, it would be kind of cool to have something maybe akin to that, and where you can just say, run COSA generate template with a few YAML config options, and it will create the COSA ingest, basically most of the things for you, all the files, the Python files that are there, or the YAML files that need to be done, and then you can go and just edit the rest that you need to manually, some kind of system like that. So I really think that, yeah, this works quite well. And also the fact that all our tooling is bundled in a Docker container has really helped us a lot with debugging and making sure that everyone is always using the same tools and the same versions, and we can easily reproduce anyone's problem because we can just run it with the same ontology and ODK version that they are using. Good. All right. Jump back. Now we will. So now the repository has been created. So let's take a quick look here at that. What this looks like. So it created basically this folder Cato. So that's the name of the ID that I gave it. You can see all of the default release artifacts here. They're all visible. Some nice contributing.md, readme.md, and then the source directory, which is okay, much more empty than the ones that we've for Pato and other ontologies, but you can see all of the main files are there, like you have the edit file for the ontology, some ID range file, and very importantly, your config file has also been copied there. So now what we are going to do is, because we have had this kind of temporary ODK tutorial directory with a seed via Docker script and the Cato the Cato config file. We don't care about that anymore. So what I will do now is I will simply move the target Cato directory to my which I should have emptied before. So I will move it to something else, Cato 2, because I don't, we don't need this temporary ODK directory anymore. So now I'm going to that instead. So cd Cato 2 ls. So that has all the files in it now. And now, okay, so you can see here, you can follow these steps that it says here. I kind of always trip over them in some way or another. I don't know why. I must have been always doing something small wrong. whenever I follow these, but please, if you, but it is working, so it's not like that it's wrong or anything. But if you follow these steps, you can use the command line to push your stuff up to GitHub. But I recommend for most purposes to actually just use something like GitHub Desktop. So you just add your local directory that you've just created in GitHub Desktop. So that's here my Cato 2. Okay. All right. And now you can see it I just opened it basically, and now it already tells me here, publish repository, publish this repository on GitHub. I'll click on it. I'll just say this is the this is the cat ontology, something like that. Give some information here. I just don't make it private. I'm giving it no organization because I want to put it in my own private area. Publish it. And now when it's done, sorry, I have a bit slightly slow internet connection. Now I can just jump there. Share it here with you. And you can see the basic infrastructure for the repository is completely there now. So now for you, what the next steps are depends on your use cases. You may want to simply open this file and start happily editing it in Protege and adding classes or some such. So this is like what many of our ontologies, so most of them are actually curated almost purely through manual edits. Or there are also some extensions for the config files that you can use to actually use a DOS-DP patterns for managing parts of the ontology, or robot templates that you can add, and other ways to add and enter terms. So this is going beyond what I wanted to discuss today. So I just wanted to show this is how you create a basic repository. I want to emphasize, before I start with questions, two important things here. So one is right now this is pretty bare. So when you jumpstart an ontology, when you don't configure anything else, you will get this GitHub action that that invokes your the ontology quality control mechanism. So you can see here, for example, that when I create a pull request, the ODK test suite will be run, and it will throw errors if there are errors. I don't even know. Maybe I can quickly just see whether I can get this to run in the 2 seconds we have left, but by just triggering it like this, root. Anyways, we'll see whether this now will trigger quickly enough for us to go over this. But yeah, so that's one of these workflows. But there are many more workflows being created right now, which are really super cool. So the system with GitHub Actions is actually works really well for continuous integration with ODK. So we have now some actions for auto deploying our documentation system. So ODK also has an automated setup for like documentation that looks, that kind of like has in the standard form looks a bit like this. So you can have like your own for your ontology. It will just create something like that and empty, and you can flash it out. And you will have actions for that. And there are no other actions for generating branch feature diffs, so that when you make a pull request, it will look, how did your classification change? And it will provide you with a diff or some such. So there are many kind of things like that. So that's a really cool thing, I think, to keep in mind, that we want to do a lot with GitHub Actions, as long as it is still free, hopefully for a long time. And this GitHub Actions, they all run, as you can see here, on the ODK container. So they have access to all of the tools that are available through ODK. So yeah, I don't know, this in the beginning, it always takes like 500 hours before the first time you're running a GitHub action actually works, but eventually it will start. Okay, I think that is what I wanted to say. Are there any questions now? Anything else you want to know? Any additional features or just clarifications?
Hey mate, hi Nico, it's Jules here. I just wanted to, with the, if you update your ontology, do all of the, or the OWL file, do all of the JSON and OBO and everything, that they get regenerated as well, do they?
Yeah. So basically, that's a very good question. So in the so when I run here let's go inside here, the source ontology directory. So if I run like the generic command for prepare release, I'm just going to do that. What will happen is that so you can see here, it will download all the dependent source ontologies, and after that it will go and automatically recreate everything. So it will recreate the imports, it will recreate the release, the ontology release files up here. It will recreate everything you want, and there are like shortcuts for just refreshing the imports, or there are shortcuts for just running the release without refreshing the imports, and some other like 50 commands that you could run to generate reports for your unsatisfiable classes and then. But yes, these will be updated. But the cool thing also is let's say we find like a bug, or we want to improve the ODK itself, then what people do, I'm just going to interrupt this here, is you can then run this command here, which is update repo, which basically which goes to the new version of your ODK if you have one, and then it will regenerate parts of the repository structure, including the Sparkle queries that are managed by the ODK and the makefile, completely based on whatever is new in the ODK. So yes, you can update both the repository structure using when you have new versions of ODK, and you can update all of the derived ontology release files with a command as well.
Right. But so you have to do that directly, only having used the OWL file though. So if you decide, I don't know, to hack the OBO file or something like that, or one of the JSON files, that won't then work.
You would never hack anything in the ODK live. If you wanted to hack, so we do have to hack in cases. We used a system for makefile overrides. So we have like this this extended makefile where you can put your own goals, and some ontologies have a huge number of them. And there we do things like, you know, hacking, like deleting definitions based on OBO grapple or some terrible command line tools that allow us to just hack into the ontology if necessary. So here you could.
Sounds like too much dirty laundry washing, Nico.
Yeah, I know. It is terrible, but we have to
let
say
them know
that
what goes into these things.
Yeah, exactly. You should never, like, we should avoid to do that as much as possible. But yes, this is where we hack things. So you do not want to hack manually a JSON file in your repo. You will always want to override the JSON goal in the extended makefile and make sure that your hack is reapplied each time you execute the entire workflow.
So the OWL file is basically the source of all truth that everything else is generated from.
Exactly, yeah. It's the OWL file plus minus. There are some other things that can be attached called components to the OWL file. So it's not just one file. It could be that there's like 2-3 files that all make up together the edit file, let's say. But yes, conceptually, that's one.
Cool.
Cool. Yeah, time check. Thank you very much for listening. And if you have any questions, ask us on the Monarch Slack or anywhere else. And thank you for listening. And I'm going to stop sharing. Thank you.